and I'll send you a copy of it to whatever email address you put in when you signed up or signed on.
Okay.
It might take till tomorrow because it takes my computer generally an evening to process all of my files, and I get them out to the students by the next morning.
Okay.
Okay. So if we start, where do you want to start here? I generally let the student direct.
Okay. So probably 13 because I got that one wrong.
Okay. I was going to say, it looks like I can tell whether you got it right or wrong here.
Yeah.
Non-vertical lines are perpendicular if their slopes are, it's not quite opposite. Here, let me take a picture of this. This is the way it usually works. It's if the two slopes are the opposite reciprocal. In other words, if one slope is 1/3, the other slope needs to be -3.
Okay.
These two slopes are perpendicular to one another. If I told you that one slope is 2, what's the slope of the perpendicular?
-1/2.
You got it. That's all you need. So it's opposite reciprocal, or however they want you to word that. To me, that's the simplest wording.
Okay.
But the way I tell students how to remember it is always remember you have to do two things. Not one, but two. You have to take the opposite, but you also have to take the reciprocal.
Okay. That makes sense.
Let's see, the next one we want to look at is 16.
No, that one's not wrong. That's just
Okay.
how many I got wrong in that part.
Okay, what's the next one we want to look at?
18.
Okay. All right, this refers to this figure here.
Yeah.
And they want to know what angle 4 and angle 8 are.
Yeah.
Let's talk about parallel lines for a moment.
Okay.
Let me bring up my, hold on a second. Yeah, let me bring up my writing page. Parallel lines and a transversal is one of the most important things you're going to learn in geometry. Okay? It really is. There's few things that you're going to get tested on more in terms of geometry than parallel lines and transversals. When I transverse two parallel lines, notice that I create 8 angles. How many unique angles do I create? Just 2.
2?
If I look at 1 and 2, notice that one of them is obtuse and one of them is acute.
Okay.
Okay? Every other angle there, if it's acute, it's the same as 2. If it's obtuse, it's the same as 1.
Oh. Okay.
Tell me what angle 6 is the same as.
Angle 2.
And what's angle 5 the same as?
Angle 1.
What's angle 7 the same as?
Angle 2 and 6.
Correct. Okay, I think you got the pattern down. Now,
Okay.
I realize the way they teach geometry. They teach you about alternate interior angles are equal.
Mm-hmm.
Then they teach you about alternate exterior angles are equal. You realize why those are called 3 and 6 are alternate interior and 1 and 8 are alternate exterior.
Yes.
Okay? And give me 2 angles that are corresponding angles.
That's the one that I'm confused on. I'm not sure what
6 and
corresponding
2,
is.
6 and 2, 1 and 5. Those are corresponding.
Okay.
In other words, they occupy the same position. 5 is the same position as 1, and they're both obtuse. So that's what corresponding is. And the fourth theorem that they want you to know is side by side.
Mm-hmm.
Well, 4 and 6 are side by side. What do 4 and 6 add up to?
10.
One's obtuse, the other is acute.
Oh, okay.
180.
Okay.
And that's
So
the
are they
other thing.
linear?
Yeah, when you cut 2 parallel lines with a transversal, the 2 angles you create are supplementary. Oh, okay. So even, and this is the situation that's tough right there. And I'm saying that they don't tell you these are right angles. In other words, let's say that's 89 degrees, that's 91 degrees.
Yeah.
So it's difficult using my original theory to do a problem like this, because my original theory says you have an acute and an obtuse angle. But in this case, you cannot figure out what is obtuse and what is acute. However, you know that's 91 because it's a vertical angle.
Yeah.
And that's 89 because it's vertical angle. Yeah. And therefore that must be 91 because it's corresponding. That's 89 because it's corresponding. That's 91 because it's vertical. That's 89 because it's vertical. So you can work it out by just knowing vertical angles and corresponding angles.
Okay.
However, I'm going to go so far as to say you're almost never going to get that situation right there where you can't tell. Almost always you get a transversal like that. And if you get a transversal like this, the only thing you need to know is which is the obtuse and which is the acute. Well, 1 is clearly obtuse, 2 is clearly acute, and every other angle here is either 1 or 2, and you merely need to recognize, well, that's 2, that's 2, that's 2, that's 1, that's obtuse, that's 1, that's 1. Okay. That's really the most important thing to understand about transverse angles. Now, let's look at this problem. The problem was, what are angles 4 and 8? Well, there's 4, it's acute, and there's 8, it's obtuse. What must they be? They're also side by side.
So are they linear?
Supplementary. Remember the number 180. I'm sure by now you have figured out that 180 is like a magic number in geometry.
Yeah.
It's the sum of the angles of a triangle, it's also what two supplementary angles total is 180. Notice that these are a linear pair. If I look at 4 and 8, you see why that's a linear pair?
Yeah.
Even without parallel lines and transversals, I would know that 4 and 8 are supplementary.
Okay.
Because whenever you have the situation where you have a straight line and another line that intersects, these two angles, A and B, always add to 180.
Okay.
Okay, and that's the situation you have there. You also have the side-by-side theorem from parallel lines, although you don't actually need that here. Let's look at 19. 10 and 15. 10 is acute. 15 is acute. Therefore what?
Are they...
Congruent. They are equal.
Oh.
Why? Because they're both acute. In other words, if I look at this, hold on a second, let me erase this. If I look at this whole picture, I got nothing but parallel lines everywhere, okay? So I know that every acute angle I'm looking at is congruent to every other acute angle. And every obtuse angle that I'm looking at is congruent to every other obtuse angle. Well, in 19, we're talking about angle 10, that's acute. Talking about angle 15, that's acute. Therefore, what must they be?
Well, they're equal.
Okay, but
So they're
in geometry, that means congruent.
congruent. Yeah.
So that's H.
So then would 20 be congruent too?
7 and 5. 7's acute, 5's acute, yes.
Okay.
How come you got that wrong? They're not supplementary for sure. In other words, the two angles that are supplementary are any acute combined with any obtuse. Well, like
Yeah.
2 and 6 are supplementary.
Mm-hmm.
2 and 11 are supplementary. In other words, the angles that are supplementary, one of them is acute, one of them is obtuse, always.
Okay.
So let's look at 22. Angle 6, obtuse. Angle 10, acute. Are they equal or are they supplementary?
Supplementary.
G. Perfect. So really, I know that they teach you those 4 theorems, but you don't really need to memorize 4 theorems.
Yeah.
You merely need to be able to know whether it's acute or obtuse. Now,
Okay.
hold on one minute. Even in the situation like this, where let's say they give you something and you can't tell which is obtuse and which is acute.
Mm-hmm.
It's the hardest problem there is. Okay?
Yeah.
And because I can't immediately recognize what's obtuse and what's acute. So tell me which angles are equal. Angle 1's equal to what? Think vertical angles.
Angle 4.
Angle 2 is equal to what?
Angle 3.
Now, angle 3 and angle 5 are equal to what? Added together.
180.
Because they're side by side.
Okay.
Angle 5 plus angle 6 is equal to what?
180.
What's angle 8 equal to?
Angle 7?
No, supplementary to angle 7. They're side by side. But it's always equal to angle 5 because it's vertical.
Okay.
Okay? So you're never going to get that. I mean, you might on some question on the SAT or something. But most of the time, the way they try to confuse you is they put in a transversal like that, and then maybe they'll add another transversal like that.
Mm-hmm.
They give you a question regarding those angles. And the biggest problem is eliminating the line that isn't important. Okay? So, let's go back and look at your problems here. I'm going to go a little bit over if that's okay. This first session is only a half-hour session.
Okay.
But since I was a little late in getting started, if it's okay with you, I'll go a few minutes overtime.
Yeah, that's perfectly fine.
I feel terrible about not being there on time. Okay, 23, do we want to look at it next?
Yes.
So they're talking about angle 4 and angle 14. Well, there's 4. 14, I assume, is this one over here.
Yeah.
Why is it not possible to have any parallel line relationships with angle 4? The line bisecting the other parallel one is shifted, so it is not possible for them to be cross-parallelly. Well, actually we do know what the relationship is between angle 4 and angle 14. They're supplementary. Yeah, one's acute, one's obtuse. Now, the only reason I can say that is because of this. In other words, I have to know that I have two sets of parallel lines. Well, see those double parallel line markers?
Yeah.
That means those two lines are parallel. See these single parallel line markers? That means those two lines are parallel.
Okay.
So I actually can, because I have a set of parallel lines, I can say that 4 is equal to 7. 7 is equal to 15. And 15 is side by side with 14. So 15 and 14 are supplementary. I'm telling you, the thing that you mainly have to remember in these things are find your acute angles, find your obtuse angles. Acute and obtuse are always supplementary. Not quite sure what they're talking about in problem 23. Because it is possible to find a parallel line relationship. And the reason it is because you have to consider two different parallel line situations. In other words, I certainly know that 4 is equal to 7, okay?
Yeah.
And 7 is equal to 15 because they're corresponding. Now, if I were to check just that, well, I would have two parallel lines and one transversal. And I know that 15 and 14 are side by side. One's obtuse, one supplement, or one is acute, therefore they add to 180. So if 14 and 15 are supplementary, then 14 and 4 are supplementary. Like I said, don't understand that because it's not true.
Okay.
Okay?
Yeah.
Not sure what's the name of your teacher at Chatfield?
Mages?
Not familiar with, is it a guy or a girl?
He's a guy.
Guy? Yeah, I don't know that name at Chatfield. I've been working with Chatfield students for about 8 years, so I know most of the teachers out there. I know that one of the main geometry teachers is Mr. Moore.
Yeah.
But I don't know the name of this one. One thing I can say is you're lucky you don't have Mr. Moore. He's hard.
Yeah.
Is what I gather from, he teaches the honors geometry out there.
Yeah.
He definitely is harder. Okay, part 1. Let's do this problem and then we'll be done with our session, if that's all right with you.
Yeah, that's fine.
Now, here again, we're looking at 2 sets of parallel lines. These 2 are parallel. Hold on, let me write. In other words, these 2 are parallel, and those 2 are parallel. Okay? So I know that every angle I'm looking at is either obtuse or acute, and oddly enough, I can't actually see because they've drawn this with some perspective.
Yeah.
But I can tell because they've labeled that one 62 degrees. So that means every adjacent angle is supplementary with 62. So A has to be 118. And that's all I need to figure out everything else. Okay. Now, the one you got wrong was C.
Yeah.
Okay. What's this number right here? Is that 11?
That's 14.
14. So if I label that 14, what's this angle right there? Hold on a moment. Let me look at this a little bit longer here. Notice something. This line here is a transversal. What's angle E based on that?
180?
14. You got it right. You said 14. Notice that that's 14. In other words, there's your 2 parallel lines.
Oh.
There's the transversal. Okay. These are alternate interior lines. Angles, excuse me. They're both acute. That's the key. When you see they're both acute, they're the same, 14 degrees.
Okay.
Okay. Now, here, let me erase some of this. The only one you missed was C and H. So let's see if we can figure out what C is. What is C?
Would C be 62?
Yeah, based on that picture only. In other words, the secret on these parallel lines and transversals is often eliminating the lines that you don't want to look at. In other words, when I'm looking at this picture, I'm looking at that parallel line, and that transversal. I'm not looking at the other line. And that is corresponding, excuse me, that is side by side with that, is it not?
Yeah.
So it's 112. Excuse me, 118.
Okay.
Okay? Now,
Okay.
the only other one you missed was H. Let me look at H. That's this one here. Well, we just figured out that C was 118, right?
Mhm.
And that's 14. What's this angle right there? Based on the fact that the sum of the angles of a triangle are 180.
It would be 180 minus 32.
Not 32, minus 132.
Yeah. Yeah. So 48?
Yeah, that angle is 48 degrees. H is a linear pair with that angle. So what's H?
So it'd be 180 minus 48. Is that how you do it?
Yes. When two angles are supplementary, you're always subtracting from 180.
So it's 132?
Yeah. A really good skill in geometry is to be able to subtract a number from 180 because you're doing it all the time. You're doing it when these parallel line problems, you're doing it when you're solving triangles, you're doing it just when you're solving two angles.
Yeah.
In other words, if I tell you angle 1 is 100 degrees, then angle 2 you got to subtract 180 minus 100.
Mhm.
So you're always subtracting from 180, so get good at it.
Okay.
Because you're going to have to do it. It's probably the most utilized skill in all of geometry is subtracting a number from 180.
Okay.
Okay?
Yep.
And that's probably a good place for us to stop this first session.
Okay.
My first sessions are only a half hour. I don't know if I told you that or not, but